Welcome, folks. What we've got is lithium-ion battery packs for DeWalt tool. What this video is about is restoring a discharged DeWalt battery that won't charge. What ends up happening is the battery will die. So you say you run out of power on your battery and you're done, you've drained it as far as it'll go in the battery pack and it just shuts off. And you take this battery out, and instead of putting it into the charger, you throw it off to the side and it sits for a month or two without getting a charge. And eventually what will happen is the battery energy stored inside of here dissipates. So every day you lose some energy off of the storage. So all this is inherent with all batteries, all types of chemistry, anything that you're working with. These batteries will dissipate a charge, and eventually when the charge drops low enough, the battery management system won't allow it to charge again. So you could put the charger in and you'll see that when you go to charge it, you get a light. There's an indicator light here. So this one's flashing red. And usually by the time it's charged, it'll be solid color. But so it's flashing right now. But when you go to put the other one in, what you'll end up doing is you'll see that instead of it being a solid red, it's going to be a flicker, and then it won't work at all. So it kind of senses the voltage in the pack, but it's not enough to get it to start. What's happening is that's a safety feature that's built into the batteries, and this will be consistent with any kind of lithium-ion battery. So if this is a battery that's inside a little RoboVac, you'd have the same situation. If it's discharged enough to where that sensor isn't kicking in to start the battery again, it'll make it appear that the battery pack is bad. But this is a real simple fix for that. The first thing that we want to talk about, though, before we show you the demonstration, is the difference in the batteries. So you got to kind of know what your battery ratings are. If you look on the back of these things, you'll see that there's some labeling here. And the first one's going to give you the voltage. So it shows here 20 volts. And then my next specification for the battery is storage capacity and amperage. So it's 1.5 amp hours. So we've got 20 volt battery. It can deliver 1.5 amps for 1 hour. So if you multiply that, 1.5 times the 20, we get 30 volt or 30 watt hours. So watts the power equivalent of Ohm's law, right? So it's voltage times amperage equals wattage. And so this is expressed in hours. So this thing will deliver 30 watts for 1 hour. And then it isn't listed on here, but it probably has a maximum output as far as continuous. It's just going to be more than 1.5 amps. These are similar. This one here says 20 volts, 1.7 amp hours, so it's a little bit more powerful. 30.8 watt hours, not significantly more, but slightly more powerful. And it also has a little light indicator on here that you can look at to see if it's got a charge or not. I don't know how handy that is. I don't really use it very often, so I don't know. I was wondering maybe if I just paid extra for this because it said power stack on the side. If you look at the batteries on top, they'll list when it's been manufactured. So this one was 2022. This one was 2018. So 4 years difference in technology. Slight improvement on the storage capacity. And it's just a slightly different configuration. So what you have here in the battery is, if you take these apart, so I've already disassembled this one just to show you what's inside of it. And if you do this, keep in mind that the screws are tamper resistant, so you have to have a special tool. I have one that has a lot of different tips on it that are tamper resistant tips, but you would need that to access these screws because they have they're like a little divot inside of there. So here we got a pack, and then this pack has cells within it. So you can see the battery cells. There's actually 5 of them in here. So to get 20 volts, these got to be around 4 volts. So there's probably 4 volts on each one of these, gives you your 20 volt pack. And then what will happen is these at 4 volts, that's fully charged. It may be 4.2, 4.3 fully charged. You're going to be above 20 volts when you're charging it, and then it drops down, but the nominal rating is 20 volts. So what will happen is we've got some circuitry here that will tell what the voltage is, either in this pack or within the charger, and it'll sense how many volts you have. So usually you need about 2.5 volts per battery. So if we have 5, that would be 10, 12.5 volts minimum in order to probably fire the charging circuit. So the voltage ends up dropping below that minimum level. The battery circuit's connected, and it doesn't sense the voltage high enough, so then it shuts it off. It won't engage the charger. So what we've got to do is we've got to trick this battery into thinking that it's got more voltage in it than what it really has. And we're not going to do this test right here, but I'm going to demonstrate it on the one that I did outside with my other battery, using a tool battery like this to jumpstart another battery. But this procedure will work. I just recommend you take it outside and conduct it out there. But the first thing we want to do is we're going to connect these terminals here. Now I flatten these out a little bit so that they'll go in. And we just press it in like that and connect this one. This is the negative terminal. And if you look closely on the battery pack, you'll see that it'll say B plus and B minus. So pluses are positive, and positive on this is indicated in red, and negative is in black. And what you don't want to do is you don't want to cross these. Like you don't want to put a negative and positive across and then connect them directly together. That ends up becoming a direct short, and it will damage the battery. So we don't want to do that. So you got to be really careful doing this procedure to observe the polarities. But basically we're just going to hook these up like this. We'll connect them, and then to do the procedure, you just tap this over onto this terminal here, the positive. So we've got B plus, B minus, and then see how you can see they're kind of crossing when you're face to face. So we're not crossing the polarity. The polarity is staying the same, but we're going to tap that on there to connect this only for a brief moment. So what I did on the test that I ran, I had my multimeter out, and I took the multimeter and I monitored the voltage rise, and I wanted to get above 15 volts on the pack that I was working with, because that one has 6 batteries in it, where this one only has 5. You can take the battery pack quantity, so if you know how many you have, you can just kind of estimate how high your voltage needs to go if you want to monitor it. If not, I mean, there's a couple of guys that just put these together and just do it right there, and I don't have any problems. But you don't want to have a thermal event, where the battery starts to go into a meltdown. So better to do it outside in a safe place. Out in your driveway probably would be best. In this case, I'm just doing this to show you how I'm connecting the wires. So we would tap that, and then these guys would kind of balance each other out, and it'll rise the voltage up on this pack here. It'll drain the voltage off of this one a little bit. And that's why you don't want to leave it on too long, because you wouldn't want to ruin your good pack. And it's fully charged, but if it's drained off to where there's not anything present in either one that can start it, now you got 2 dead packs. So you want to be careful about that. It's only for a few seconds, 5 to 10 seconds probably. Maybe the first time you do it, 15 seconds at the most. Hold it there, give it some time, check it, see if it'll charge. And if not, put it through the procedure again, check it again, see if it'll charge. Very simple. It's a very simple thing to do. Anyways, that's pretty much about it for getting one jump started. So if you got a dead battery and you got a bunch of these tool batteries, which a lot of people do, this is a real simple procedure to do this. So here I'm just using a 14 gauge wire that I got on a piece of Romex, and I crushed the ends of it so that it was flat, so that the conductor is flat. That makes it a little bit easier to insert into the thing without damaging it. You can see it's kind of flat there on the end. And that's basically about it for this. But let me show you how I did the battery test, and then you can see with another battery doing the same procedure. And what you want to do with the other battery is identify the voltage, so if you know what your voltage is, and if they're not matched, like in my case I had a 22 volt battery pack, whereas this is a 20 volt. They don't have to be exact, but probably a good idea to get close. Or you might try a resistor in your circuit to kind of keep the voltage down. And, that's something I haven't done that, but if I did a dead skateboard battery and I had a 15 volt or 12 volt or something, I really wouldn't want to use a 20 volt pack to try to jump start that without like maybe resistoring it down so that I wasn't applying too much voltage, because you could damage the other battery if you raise the voltage too high. It'll just fry them, so we don't want to do that. So we want to get closely matched. These are definitely matched exactly the same, 20 volts, so there's not too much difference there. But in our case, the boost fin battery, we had a 22.5 volt system there, but it was basically the same thing. It's just these lithium-ion batteries in packs where they solder them together. In that case, it had a little bit more primitive circuiting, so you can see the circuiting in the pack, but it's there, it exists. And so I had to take that one apart to get to the battery output circuit, whereas with these, this is readily available right here. You don't have to take anything apart. The only reason why I took this apart was so we could look inside of it. But yeah, that's pretty much about it for the battery. Watch the rest of this, and if you liked it, give me a like, and if not, maybe leave a comment or something to let me know what I could do to make the video better for you, because I really want to try to improve my skills in producing videos. I'm trying to learn how to be a better speaker, more articulate, and make things more interesting for everyone if they're watching this, so they'll get more likes. .5 volts. Okay, I've kick-started it. Got the red light, it's not working. This wraps up today's video. Of course, we're just jump starting a battery, so we had a failed condition in a DeWalt battery pack, and I didn't really go through all the steps, but the other one, I'd already done this once, so that's how I ended up with the battery footage to begin with. So I just used that from the a boost fin pack. So if you're interested in how a boost fin is assembled, I suggest you watch that video. It's a little longer than this one. This is just basically just talking about lithium-ion battery packs in general. So you can probably do this procedure with just about any battery that you've got that you think has failed. So if you're dealing with, like I said, a RoboVac, or maybe a skateboard battery, or hoverboard, something small that would be running around 20 volts, and you can do this procedure. Now, one of the guys says that this is the same as a golf cart situation where the battery's in a golf cart drain. Depending on the battery technology, that might not be the case, because with lead acid batteries, you're really just getting down to the point where the charger just doesn't have enough oomph to start it. And so in that situation, in a golf cart, you probably don't really want to mess around with that too much. And he recommends taking each battery out and charging it. And actually, that's maybe not a good idea either. To get it started, I could see maybe doing this procedure on each battery separately, just to get the voltage up a little bit, but not to add too much current in there, because you get an imbalance between the batteries, and then it won't charge correctly. You'll get one that's got more current in it than other ones, and that'll be the limiting factor for the rest of the batteries, and it'll always have an out of balance pack. So whenever you're working with batteries that are in series and you're charging them, keep them in series and charge them that way. You don't want to charge them separately. If it's lithium-ion, well, that's a whole different deal there. And then like a car battery, well, what happens with a car battery when it goes dead is it just doesn't have enough current to get the motor started, so you have to jumper it. So what we do with a car battery is we put jumpers cable, same principle as what we're doing here, except for what we're trying to do is raise the current capacity to turn over the starter motor. So you want to fire up the starter motor, you need more current. Well, those two batteries together in parallel develop more current and will start the system. So that's a different procedure than what this is. So keep that in mind, but always be safe, wear safety goggles. Like I recommend, do it outside just in case, because you're working with electronics, and batteries can have a thermal runaway, so you really don't want to have that happen to you. But just have to be extra careful when doing this kind of thing. So when you're starting to connect batteries together, just pay attention to the safety features, that are inherent. And if you're not used to working with electricity or anything like that, this might not be something that you want to attempt. But for most people, this isn't going to shock you. The voltage isn't high enough to cause a shock or electrocution or anything like that, so you don't have to be worried about that. We're mainly concerned about transferring heat. So if we get a heat buildup and we get one of our cells starts to get too hot, that's why you only do this momentary. You don't want to do it, just turn it on and leave it, because that'll probably create a situation where you could have a meltdown. But we're here, we're monitoring it, it's momentary. So if we see any heat, if you see smoke, stand back. It might just explode all of a sudden, because that's what happens when the batteries are damaged like that, a thermal issue. These are probably one of the safest, so they wouldn't have them in so many electronics if they weren't. So these are lithium-ion batteries. So you could have lithium phosphate. There's different chemistries that they work with, or battery technologies out there. So just be aware that this may not work for something else. Lead acid battery wouldn't be the same. Charging system doesn't work the same. So different batteries have different situations, and what's happening here is just a safety feature that's built into the charging circuit. So you got, $75, $50 maybe for a charger pack. And if it's just got the voltage dropped a little bit, you can save yourself $50 by jumpering it and just putting it together and seeing if that'll work for you or not. And then what I recommend is, after you do the 10 seconds or so, or 15 seconds of charge, test it in the charger. If it charges, leave it in there and let it run through its charging cycle, and then it'll be back to brand new again. It'll be the same as what it was before. And eventually it's going to wear out, but the cycles on lithium batteries are 500,000 cycles without actually losing any capacity, so they can last for a very long time. And so if you're just letting it sit around, chances are that's what's happened to the battery. It's not bad, it's just drained it down far enough that it's not working anymore. And if you got a tester, test it to see if you got any voltage present. And if there is some voltage present, then it's definitely going to be a good candidate for this procedure. And if not, then maybe you do have a bad battery. If it's completely dead, the chances are it's shorted out. The cells are shorted out in the circuitry, and you probably can't get it to fire back up. But like with the battery that I was working on for the boost fin, I had a 3.5 volts present. I mean, that's not very much on 6 cells, but it was enough present, maybe half a volt per cell, to get it to fire up. So it still had the capacity to take a storage, and it would still work. So we kind of knew how long it had been in storage, so it hadn't worked for a year or so, and it's been sitting there, and somebody didn't bother to keep it charged because they weren't using it. That's the main reason why that didn't work out. And if you can, with your drill batteries, try to rotate them. Rotate the stock, make sure that you're using them regularly to keep them charged and keep them consistent, and those will last for a long time like that. So anyways, that's all I got to contribute to the battery video, and I hope you enjoy it, and if so, fire up the like button. Likes, I definitely need likes, I need comments, and if you can, subscribe, because we do want subscribers. I got some stuff coming out with Kathy with her mosaics that she's done, so we'll be doing mosaics. We'll just do different things. So anything that is of interest, especially in our situation where we live in a mobile home community, and these kind of things are just things that we do, to take care of ourselves. It's a simple procedure, and it could save you a lot of money. This is going to be Ron signing off. We'll see you on the next video.